We have some tougher ones to do today. You should, at this point, know that the product rule says if I have a u times a v and I want to take the derivative, it's going to be u prime v plus v prime u. And you should already know that u over v, if I take the derivative, is going to be u prime v minus v prime u over v squared. You've learned the quotient rule enough by now. And in the last lecture, we pointed out that a to the x, if you want to take the derivative of that, is equal to a to the x natural log of a. That's probably going to come in handy. And the chain rule, which is the whole reason we're here, says that if you want to take a d dx of an f of g of x, you will get f prime g times g prime. The derivative of the outside with the original input times the derivative of the inside. Okay, so the first question gives us an obvious quotient. It says f of x is equal to x squared plus 1 over x squared minus 1, and that whole quantity is cubed. Now, what's the outside function? Maybe it's the cube, and the quotient here is the inside function. So f prime points to the cube. And if I want f prime, I'm going to get 3 and something squared, right? And in order to do this g prime, I'm going to need the derivative of this. So let's just go ahead and solve that inside quotient first. For my u, I'm going to make it x squared plus 1. For my v, I'm going to make it x squared minus 1. So u prime is 2x, that's a power rule. V prime is 2x, that's a power rule. So we'll take that and we'll do u prime 2x times x squared minus 1 for v minus 2x v prime times u, x squared plus 1. And if I want to condense this a little, we could write it like this. We can take the parentheses away. The x squareds will cancel off. This is going to become a minus 2 in here, isn't it? So we're going to get a negative 4x on top, and it's divided by v squared. So that's x squared minus 1 squared. So that in itself is just going to be our g prime here, the derivative of the quotient on the inside. Now we can go about our business now that we know that. So take our derivative. I'll draw an arrow here so we don't get too lost. It's going to be 3 polynomial power rule, right? X squared plus 1 over x squared minus 1 squared times this baloney over here. So let's see how we can simplify it. Well, this minus 4 and this 3 can go together, right? So we can write minus 12x times x squared plus 1 squared divided by, this is going to be x squared minus 1 to the 4th. That's the answer. I know I whipped through that pretty quickly, but you can play it back on slow if you want. The point of this is to understand that the power rule is on the outside, but the quotient rule is on the inside. We had to use them both. Let's move to the next question, because there's a few of them on here. It's going to be hard. That one felt a little hard. I hope I didn't get it wrong. Nah, that would never happen. So we'll cross this guy off. I'll wait to the end. And we'll do the next one, which says f of x is equal to, and I'm going to immediately change it to an exponent, 1 plus 2e to the 3x to the 1/2 power. That's what square roots are. What's my outside function? This. What's my inside function? This. This is my extra inside function. So it's layered within layered. We'll be careful about that. So f prime of x is equal to 1/2 1 plus 2e to the 3x to the negative 1/2 times the derivative of the inside, which is 2e to the 3x times the derivative of the inside again, which is 3. So this 2 and this 2 will cancel, and we're going to get 3e to the 3x times 1 plus 2e to the 3x to the negative 1/2. Now we'll rewrite it back into math teacher happy look, which is 3e to the 3x over the square root. Negative 1/2 means put it on the bottom and make it a square root. 1 plus 2e to the 3x. Now let's have a look and see if that feels right. Feels pretty good to me. It should be 3e to the 3x. This is the correct answer. Okay, excellent. That was kind of a quick walkthrough, but it was a lot alike. We didn't do a quotient rule there, but you do the power rule, and then you pull it out and chain rule, chain rule. Let's do another one. How about this next one? This might get tricky, actually. F of x equals 5 to the negative 1 over x. So we're looking at this rule here, plus some maybe other stuff, because this is chain rule, and you don't know the derivative of this yet, which we're going to need. So we'll do one thing at a time. We know f prime of x is going to be the same as the input, goes right here, so it's going to be 5 to the negative 1 over x times ln of 5 times the derivative of the inside function. You see, because it's not 5 to the x here, like it is in the rule. It's negative 1 over x. So we're chain ruling this. So what do? Let's come down here and work on it. Here's our quotient. So we're going to do the quotient rule, u prime v minus v prime u over v squared. U is negative 1. U prime is 0. V is x, and v prime is 1. So 0 x minus 1 times minus 1 all over x squared. So it's obviously going to become a positive 1, and this goes away. So we get 1 over x squared here. And that means we're going to have ln of 5 times 5 to the negative 1 over x squared. How do you feel about that? I believe this is the correct answer. Let's do one more, since we have it here. Let's do one more. You can do one more. Does your brain hurt? It's just chain rule, product rule, quotient rule. We're just combining them, doing them in funny orders, pulling things apart. It's kind of like looking at the inside of an onion and try to put the layers together from the inside out and upside down. So this one is a function of r. Unless r is a number, then this is f of r equals r. And here's what I'm going to do, something sneaky, because I don't like using the quotient rule. It's extra work. I'm going to do r times r squared plus 1 to the negative 1/2. That's allowed. Now it's a product rule. And we know that that's u prime v plus v prime u. So what's our u? Well, that's r. And u prime is 1. Our v is this ugly statement here. And v prime is, it's a chain rule. First we bring the power down, keep this inside the same, and then we have to multiply by the derivative of the inside, like that. These cancel, so it's going to be negative r times r squared plus 1 to the negative 3/2. Now we have the things we need to put this together, don't we? So u prime is 1, v r squared plus 1 to the negative 1/2 plus v prime, which is what we just came up with there, times u, which is r. Whew, Okay, so that's going to give us 1 over the square root of r squared plus 1. Your math teacher doesn't like to see negative half as an exponent. Hurts their brain. Minus r squared over r squared plus 1 to the 3 halves. And what does the 3 halves mean? What does the 3 halves mean? It's the same as saying it like this. I'm going to rewrite it for you. Square root of r squared plus 1 minus r squared over, this is important, r squared plus 1 cubed underneath the square root. And if you wanted to put these together for some reason, we can do r squared plus 1, but I think it's just going to make it more complex. So I might just leave them apart like this. Let me think on this for a second. What do you guys think? I don't know that it could be nicer looking than this here. That should be the right answer. So these are some more examples of using the chain rule within the product rule, within the quotient rule, exponential, and even the natural log rule popped up in this one. I'm going to try some more complex ones in the next video.